Hello, I'm Nick with Mayro Power Systems, and basically what I'm showing here is the difference between AGM batteries and lithium batteries. So I'm going to turn around over here. I have two Optima D27M, so these are 27 series AGM batteries, 66 amp hours apiece. Putting the two of these together, so that's going to take us about 132 amp hours, and I'm going to compare that with our 125 amp hour lithium. So to do the test, I'm going to be running our 7000 BTU DC unit, and I'm going to be monitoring how many amp hours to get out of the battery and how much runtime I get out of the unit. The runtime is going to be a bit easier with the lithium battery, as once the voltage gets too low, it'll cut out automatically, so this number won't change. On the AGMs, I'm going to do my best. We'll have a good reading as far as the amp hours go, but as far as the running time, the unit will shut down at a low voltage protection, but it will continue to draw from the control, so that running time may be skewed. So I'll see what I can do with this. And running it, I also have the pump hooked up and circulating through my little condensate bucket, so that way I'm getting an accurate reading as far as what kind of runtime I can expect as well out of the 7000 BTU unit. Right now, the charger is on. What I want to show is that, I don't know if you can read this, but I'm now putting 0 amps into the batteries. The batteries are 100% charged. I'm going to use the same charger. I have different leads over here as well, because I have a secondary lithium battery charger that I have mounted under this table, but it's going to be disconnected. While I'm running these batteries, I'm going to charge up this battery with just the AGM charger. So I'm not going to charge it to 100%, but I will get very close. And we're going to do the testing, so you'll see how everything goes. What I would like to do actually is I'm going to disconnect this now. So now the charger's off. We're going to see our voltage drop down over here. See at 13.5, it's going to go down to 13.4. And I'm going to turn, so now it's powered. I'm going to turn on the control. So the pump just turned on. It is drawing less than an amp at 12 volts. So we can see the pump over here circulating water in this little bucket here. Obviously we can increase that consumption a bit with or restricted runs, but this will give us a good idea. So now we have the compressor that just kicked on. I am going to adjust this temperature a little bit because I want the test to be with the unit running at full speed. With these DC compressors, we don't have a spike, so right now I'm drawing 24.6 amps. That will increase. We'll see that go up to maybe 26. Although we do have a colder temperature here in this room, it's inside the warehouse, so it's not quite as hot as where you're going to find 90 degrees, 100 degrees inside of a boat outside. But if you look at that voltage, it's amazing. We're already down to 12.5 volts. 12.4. So we've been running for 2 minutes, and these are the results so far. I'm gonna leave this thing running. I'm gonna run out and do a few things, and we'll see what I run into when I get back. So we're gonna turn this on now. you can look up this charger, SBC 500 NRG. It's made by Quick Nautical Equipment. This charger does not have a lithium function, so right now we're set to AGM. And it's a 40 amp. And this is the same charge that I use to charge the AGM batteries, to compare apples for apples on just a drop-in replacement if I don't want to add anything else. Alright, so I'm back here again. We have the two AGM batteries. AC unit's still running. We're down to 10.7 volts, so we're drawing 29 amps. So the amperage is going to increase as the voltage goes down. It has been running for a little over, we'll say a little over 3.5 hours. But we are down to 10.7 volts. This is going to be a critical point for a lot of electronics. So if you're using these as a house battery, that's not going to be very ideal. As well as the, I mean, this is going to greatly damage the amount of cycles in these batteries. 10.7, the batteries are dead. They really shouldn't be running anymore now. I'm going to take them down to 10.5 just to make a point. So I've now hit my 10.5 threshold. I'm not going to take the batteries any lower than this, otherwise there will be nothing left of them. I've been able to use 105 amp hours of capacity, and I've ran for 3 hours and 42 minutes. Now I'm going to shut this off, and I'm going to hook up the lithium battery. So right now I have the charger hooked up. So looking here at the lithium battery, I'm at 13.6 volts. I'm not fully charged, but this will suffice for the testing. Once again, haven't hooked up any other charger. This is the only charger hooked up, which is the Quick SBC 500, so it's a 40 amp set for AGM, not for lithium. So I'm going to do the same test now and show what kind of time we're getting out of this. Okay, so we're going to go over this again. I have the lithium battery hooked up. These two leads are from the lithium charger. These leads are loose inside. You can see the little ring terminal hiding inside. So that's why these caps are on. It's just to show that the only leads are the power leads that are feeding the breaker and the shunt. So we're starting this off with the battery at 13.7 per the meter. I've reset the time, I've reset the amp hours, and I'm going to kick this back on. One thing I also want to note, compressor kicked on, you're going to see that the amperage never spikes. The amperage slowly increases. So we don't have that compressor surge that you would see on traditional 110 volt air conditioning systems. AC is on. I'm still above 13 volts. I went from 13.7, I've dropped now to 13.2. If we look over here, the unit's been running for 18 minutes. We've used 8 amp hours. Voltage is at 12.9 volts. I'm going to keep this unit running. I'll check it in the morning. By that point, the BMS will have kicked in. We'll have turned off the unit, which will stop this meter here. So once we turn the unit back, once we turn the battery back on or reset the BMS, it'll allow us to see what kind of time it ran for, how many amp hours we got out of the battery, And then of course we'll see what the voltage is at, but we're going to see it in the high 11s. We have no power to this display here. So we'll turn off power to the unit. Display's off, so BMS kicked in. So I'm going to reset it now. Down to 27%. 12.3 volts, so it dropped down, but then it came back up. But anyways, looking at that, so I still have a little bit left in that battery to be able to continue to run. I was able to get an hour more than I was on the AGM bank. Got 127 amp hours out of the 125 amp hour battery, and still have more inside of it. And so, comparing now, 32 pounds, 33 pounds versus 109 pounds. Look at the size, and the main thing is also to get to a decent runtime, we had to take these batteries down very low. We had to go down below, or go down to 10.5 volts. This battery cuts out at 11.7 volts. So it's a pretty substantial difference for sensitive electronics on the boat. On top of all the smart features, so you see that this battery shut itself down. I had to physically reset it. So it protects itself from low voltage. These batteries will go down until they die, causing permanent damage to the cells, but they'll just keep discharging. You can take these batteries down to, you could take them down to 2 volts. If you just keep a load on them, you could take them down to, I mean, you could kill them completely, whereas it is impossible to do that with these batteries. We have temp protections, we have load protections, we have charge protections. You can't overcharge these batteries, you can overheat them, whereas once again, these are just kind of the dumb batteries that you can do whatever you want with them. They'll take whatever you give them, but you can cause permanent damage to them very quickly.